Lesson 12-2, Evaluating Limits. So we discovered in the previous lesson that for many limits you can just plug in the value of x. But what if that gives you 0 over 0? Amazingly, 0 divided by 0 is sometimes 0, sometimes undefined. Sometimes it's dividing by 0 and is undefined. Sometimes it equals 1 or a half or 16. You don't know what 0 divided by 0 equals. It's called the indeterminate form. So we have a couple techniques for evaluating limits that are in the indeterminate form. This is very important for calculus. One is called the dividing out technique. You factor, cancel your common factors, and then maybe you can find the limit. So let's find this limit. Well, we could try just plugging it in. So it'd be 9 minus 24 plus 15 over 0. Oh, divided by 0. Oh, we have 0 over 0. Well, that's not particularly useful. So let's try the dividing out technique. So let's factor. We're not taking the limit yet, so we still have to have the limit symbol. So on the top, to get the x squared, could be x and x. To get the 15, could be negative 5 and negative 3, which adds to make the negative 8. And then the x minus 3's could cancel. Now we could just plug in the x value. So we'll have 3 minus 5, which is negative 2. So look, we've evaluated a limit. That was 0 over 0. So in this case, 0 divided by 0 is negative 2. If we were to graph this, here's where x is 3. The y value is negative 2. Even though when you graph it, there is a hole in the function there. Because when you divide by 3, when you plug in a 3, you'll be divided by 0. Therefore, it's undefined and has a hole in the graph. But we can still find the limit at that hole. Another technique for evaluating the indeterminate form is the rationalizing technique. And this is when we have radicals. So what we could do is get radicals out of the numerator by multiplying by the conjugate of the numerator. Let's evaluate the limit as x approaches 0 of the square root of x. All right, you can see it. So let's try plugging in the 0. Well, on the top, I'll have 3 minus 3, which is 0 over 0. So yes, this is the indeterminate form, so we need some other technique. So what we could do is we could multiply by the conjugate, so that's the same thing, only the opposite sign, so it's plus 3 instead of the minus 3. And do that to the top and bottom. See what we get. When you multiply a square root by itself, square roots cancel out. Then I have 3 times the square root. And then minus 3 times the square root, which will cancel out, and minus 9. On the bottom, I'm not going to multiply it. It's easier if I just leave it. So those cancel out, and 9 minus 9 cancels out, so I'm not evaluating the limit yet, so I still have to have the limit symbol. Oh, and then the x's cancel out. So I have 1 over that. Now I can evaluate the limit by plugging in the 0. So it'll be 1 over 3 plus 3, or 1 over 6. So in this case, the limit is, 0 over 0 is 1 over 6. There are also one-sided limits, which are limits found from only one direction. When we have the minus with our limit, we're going from the left, or the negative direction. If it has a plus, we'll be coming from the right, which is the positive direction. So let's evaluate the limit as x approaches 0 from the left of the absolute value of x over 4x. Well, here's a graph of it, or we could make a table. If we plug in the 0, we'll get 0 over 0. But notice, from the left, that way, we're at negative 1/4. From the right, this way, it's approaching positive 1/4. Since it's approaching different values, the total limit as x approaches 0 doesn't exist. But one-sided limits do exist here, because it does approach one number from each side. Now let's have a limit from calculus. It should look familiar. We've seen it quite a few times during this year, only now we've put the limit as h approaches 0. And this always gives the indeterminate case. Because notice on top, the top would simplify to f of x minus f of x, which is 0. And if h is 0, the bottom would be 0. All right, for the function, f of x equals 2x squared plus 1, find that. All right, so here's how it's going to go. We're going to take this and plug it in for x. All right, so the limit as h approaches 0, so all of this becomes 2x, but x is 2 plus h squared plus 1. So this is 2x squared plus 1. That's my f of x. Minus f of 2. So it's 2x, but x is 2, squared plus 1. So this again is 2x squared plus 1 over h. Okay, let's do some simplifying. 2 plus h squared being used binomial theorem. Oops, that's not squared. And this would become 2 squared is 4 times 2 is 8 plus 1 is 9. Just keep simplifying. We can distribute. Okay, the 8 and 1 cancels with the 9. On the top, they both have an h, so we could factor out the h on the top. And then that'll cancel with the h on the bottom. And now we could plug in our 0 and evaluate the limits. It'll be 8 plus 2 times 0, which is 8. So that limit comes out to be 8.